Hello everybody. Welcome to your first official instructional video for Pre-AP Algebra 2 here in our continuous learning for second semester 2020. We are going to be starting with lesson 12.1, which is going to be a review lesson. We're going to start you guys out nice and successfully this week to make sure that you're getting used to the structure and the system without pushing you too hard mathematically. So for this review, we are going to be reviewing right triangle trigonometry. Right triangle trigonometry. So trigonometry is a branch of mathematics that deals with the relationships between sides and angles in triangles, specifically for our purposes in right triangles. Not only are these obvious in triangles, but we are also then going to relate trigonometry to relative trig functions this year. So not only are we going to be studying triangles, but we are also going to be studying how those look as trig functions. So here's going to be your primary difference from geometry last year, what goes on when we unroll those trig functions caused by the angles and the sides. So to start out, make sure that you've got paper, make sure that you've got a bunch of highlighters, a bunch of colors. Here's all mine. Just to make sure that you're good and ready to go, or you could just sit and soak it all up. You can always pause when you need to. Okay, so away we go. The first thing we're going to look at is a set of ratios, or trigonometric ratios. I'll just write trig ratios in a right triangle that are the same no matter what the size or the angles of any triangle. Last year you discovered a bunch of these trig ratios in geometry. Again, today is just going to be a review. So just a quick review about a right triangle. I draw pretty generic triangles. Geometry is not one of my passions. So as I'm looking at this triangle, here's your right angle, just as a quick review, which means that right angle is going to be pointing directly at the hypotenuse. Then we're looking at what we are going to refer to as your two legs of your triangle. Once again, one thing that we have looked at this year is, of course, good old Pythagoras. So we've got the Pythagorean theorem, which says that leg squared plus leg squared equals hypotenuse squared, and that would be good to remember as you move forward here a little bit. Another thing that we can do is we can focus down on one of these acute angles in a triangle. They have to be acute because, as you know, the triangle sum theorem says that all of the angles in a triangle add up to 180. So adding up to 180. Just quick reviews from geometry. So if I maybe narrow my focus here to look at this angle, this little acute angle, I'll call it angle theta. I'll try to write some things that I'm saying. So here's angle theta. We typically use Greek letters to refer to angles, and theta is probably our most common. When I look at the angle theta, we're going to talk about different pieces in this triangle. This leg is going to be the corresponding side to that angle, and this leg is also located on the opposite side of this triangle from this angle, which means that this leg of the triangle is going to be located directly next to that angle, and we call that your adjacent piece or your adjacent leg of the triangle. So two key words here, opposite and adjacent, in order to go with our hypotenuse. I'm assuming that you are remembering back to your wonderful instruction from last year where you should start to be thinking about those set of ratios, which of course are going to be sine, cosine, and tangent, which relate to the acute angles and the pieces in the triangle. So just as a review, we've got sine. So sine of any angle in a triangle is going to be equal to the opposite piece divided by the hypotenuse piece. We've got sine of any angle is going to be the ratio of the opposite over the hypotenuse. Then, of course, we've got cosine. So our cosine of any angle in the triangle is going to be equal to adjacent over hypotenuse, or cosine of your angle is adjacent over hypotenuse. And then, of course, our last one is going to be tangent. Which then is going to be the tangent of any angle is going to be equivalent to the ratio of the opposite piece divided by the adjacent piece. So these are going to be your favorite trig ratios, which exist in any right triangle: sine, cosine, tangent. It's easiest to remember them by SOHCAHTOA, of course. I like to write mine like this. In the past years, if I just write like you've kind of always seen it, some of my students forget which one needs to go in the numerator and which one is the denominator, so I tend to write it out like that. So another thing that, I can't remember if you discussed this last year or not, that goes along with these trig functions is this idea of what's called reciprocal functions. So this year we are also going to be looking at reciprocal functions. And of course, reciprocal functions are going to be, instead of opposite divided by hypotenuse, we're going with hypotenuse over opposite, or 1 over sine of that angle. So sine of any angle has a reciprocal function that is called the cosecant of your angle. And the cosecant of your angle is listed as CSC. Cosecant of any angle is going to be the reciprocal, or 1 over sine, which will end up being hypotenuse divided by the opposite piece. So as you can see, reciprocal instead of opposite over hypotenuse, we've got hypotenuse over opposite. Okay, reciprocal function for cosine is going to be secant of any angle, and its abbreviation is secant, which is going to be 1 over cosine, or hypotenuse over adjacent. And then the very last one deals with this tangent, and I'm going to have the cotangent, if I can spell right, cotangent, which is going to be COT of any angle, which is 1 over the tan, or adjacent over opposite. So rather than just our 3 trig functions, we actually end up with 6 trig functions. Another thing that's kind of cool about tangent is tangent can also be seen as sine over cosine. And the reason why tangent can also be sine over cosine, and it'll work no matter what, is if you think about what sine is going to be opposite over hypotenuse. So if I divide opposite over hypotenuse divided by cosine is going to be adjacent over hypotenuse. If I divide these two ratios, I always like to look at it as, instead of dividing by adjacent over hypotenuse, I'm going to multiply by the inverse, hypotenuse over adjacent. You can see that the hypotenuse is going to divide out, and I will end up with opposite over adjacent, which is exactly what tangent is no matter what. So if you think about that for cotangent, if you're going to end up with adjacent over opposite, cotangent is actually going to be cosine over sine, which would make sense based on the fact that it's a reciprocal function as well. So if I'm looking back at my 6 functions, I've got sine, cosine, tangent, cosecant, secant, and cotangent as my 6 trig functions of utmost importance as we move forward. In the olden days, we used to look at these ratios. They used to have just books and books and lists of these ratios that they would have to carry around with them. Luckily now, in these days, we've got our trusty calculators. So here's my graphing calculator. The most important thing is, as we're looking at triangles for now, we're going to be sticking with degree mode. So if I go to mode, when your calculator has been, the memory has been cleared or it's been off, it is going to automatically set into radian mode, which means the first thing I'm going to do is make sure that I am in degree mode when calculating several of these. And as you can see, there's your sine, cosine, and tangent. You'll notice that you've also got your inverse sine, cosine, tangents, which are not going to be the same as your reciprocal functions. So be careful about that one. Okay, so let's make a little bit of sense of these in a triangle. So if I were going to look at a generic triangle, let's say, I'm going to draw some triangle right here. There we go. So here's example 1. I've got some random triangle. I've got, let's say we've got 5 here and 13 here. And let's look at this angle, theta, down there in the corner. And let's say that I was going to ask you, so what are the 6 ratios for this particular triangle? Okay, so well, first of all, if I'm looking at this piece, let's identify which pieces I have. All the way across on the opposite side of the triangle, this is going to be my opposite piece. The right angle is pointing here, which means there's my hypotenuse, which means, of course, I'm missing my adjacent leg of the triangle, which means we're going to have to use good old Pythagoras in order to figure that one out. So we've got, I'm just going to do it quick over here, 5 squared plus I don't know what squared equals 13 squared. So 169 minus 25 is going to be 144. Square root. I end up with a side length of 12, which makes perfect sense to me because I'm remembering, oh yeah, 5, 12, 13, special right triangle. Okay, so now, of course, we have our adjacent piece. There we go. Which sets us up to make our 6 ratios. So I'm just going to start with my sine. I've got sine of angle theta. So I'm looking back here. I've got my opposite piece, 5, over hypotenuse of 13. And I'm good for now to leave it like that. If you would like to put it into decimal form, go for it. Cosine of theta is going to be adjacent over hypotenuse. So my adjacent piece, that's why I like to label my triangle right away according to an angle, because then I can just cruise. Adjacent over hypotenuse. I don't have to think too many times. Make it quick. Tangent of my angle is going to be opposite over adjacent. So I've got 5 over 12. All right, so now sine is going to be cosecant. So I'm going to use sine in order to get the cosecant of my angle. I already did the thinking. Reciprocal function, 13 over 5, boom, done, move along. Cosine goes with secant. So the secant of my angle is going to be 13 over 12. And then cotangent of my angle is going to be 12 over 5. And right there, 6 reciprocal functions, practicing with your opposite, adjacent, and hypotenuse. The more familiar you can get with sine, cosine, tangent, the better your life is going to be in the next couple weeks here as we continue forward. Let's kick it up just one little notch. I got 2 more things to show you before we're done for the day, and I'm out of paper here. So moving on to page 2, I'm gonna just make a little quick TOA. Again, just a little cheat sheet so I don't have to, as I'm figuring things out, I need to make sure I have just a quick reference to go for. Another thing that we can do in a triangle, let's say that I keep my same one. We already did all the work. Why not? I had my 5 and my 12 and my 13, and we called this theta. Another thing that we can do is we can use our trig ratios in order to figure out angles of a triangle. So in order to figure out angle of this triangle, you can choose any of the pieces that you wish. We already had them labeled. Here's going to be your opposite and your adjacent and your hypotenuse. The first one that jumps out at me is sine. So in order to figure out this angle of a triangle, so this one would be finding angles. This is kind of the tougher one rather than finding sides. We'll do that in a minute. So finding angles, if I'm missing that angle, let's say I wanted to use sine. You could use any of the ratios if you have all the pieces. So sine of that angle is going to be the opposite piece, 5, divided by the hypotenuse, 13. We already figured that out. But now, as you'll notice, the only unknown that we have is this theta. So if I want to solve for theta, that means I need to undo what's being done to theta. In this case, we need to undo sine. Well, how do you undo anything? I hope that you're screaming right now, inverse, inverse, yes. So we need to undo sine by applying my sine inverse, which means theta is going to be sine inverse of 5 over 13. At this point, it's going to be calculator time because it is 2020, which is very convenient. I'm checking my mode as I have been just programmed to do. And I am going to now implore that sine inverse. So I'm going second sine inverse, 5 divided by 13. And I end up with 22.62, check out that rounding, degrees, which makes sense as a degree of a triangle. So I'm going to go with 22.62 degrees is going to be my theta. Now, you want to make sure that it's going to make sense in this triangle, and it does. If this angle is 90 degrees, I only have 90 degrees left to split between these two. 5 is considerably smaller, which means that the opposite or corresponding angle is going to be considerably smaller, leaving 67 point some left for that bigger angle, which again makes sense to me. All right, so now that we've kind of gone through that tough one, let's do one more, except this time I actually want you to solve. Solve the triangle. Solving the triangle means I need all of the angles and all of the sides. So let's say I end up with a straight line there. There's my right angle. We can call this L, M, and K. And let's say that my givens are 9.6 and 8.4. So solving this triangle, I know that I am missing this piece of the triangle and 2 of my angles. I would probably say let's find the missing piece first. Let's find this little k, this leg right here. Again, we're missing one of our legs, so let's use Pythagoras. So I've got 8.4 squared plus I don't know what squared equals 9.6 squared. Okay, I don't have this done ahead of time. So I'm going to do 9.6 squared minus 8.4 squared because I know I'm going to have to undo that plus 8.4 squared. I end up with 21.6. So I've got b squared equals 21.6, which means square root, square root. Square rooting my answer gives me a side length of 4.65. 4.64. Let's see. I was given in tenths, which means I'll go back to this and round for tenths just to stay consistent. So I know that this one here is 4.6. I'm actually going to highlight it because this was not a given, which means that I could have made a mistake somewhere along the road. So as I'm trying to solve for my missing angles, I'm probably not going to use this if I don't have to. All right, so let's try to find this angle, call it angle theta. Now I could use 4.6, but I might have rounded incorrectly, who knows what. So I'm gonna stick with what I've got. These two pieces. Compared with this angle, I am looking at an opposite piece. And also there's that right angle. So this is adjacent, but it actually is going to be your hypotenuse because hypotenuse always wins. It's got the most power. So if I'm looking at O and H, and I go back up here, I'm looking at sine of that angle once again. All right, so I've got sine of I don't know what is going to be equal to 8.4 divided by 9.6. This reminds me of the one that we did above. I'm missing this angle, which means I need to undo sine, which means I'm going for the sine inverse of that ratio. Again, you can see some call it lazy, some just call it I need to do this quickly. So I'm going second inverse sine, 8.4 divided by 9.6. I'm hoping some of this is coming back to you. If not, remember that you've got a set of practice problems out of your book tonight. My angle looks like it's going to be 61.04 degrees. So you've got some practice problems to help you. And again, we will have Zoom sessions to answer your questions. They are optional only if you need to have some of your questions answered. If you feel like you're good to go, no reason to attend the Zoom sessions tomorrow. All right, so there's one of my angles, 61.04 degrees. I'm also missing this angle over here, which we could call alpha or beta or any other Greek letter we choose. And I could use trig, or what do you remember about all the angles in a triangle? Let's call this little alpha. They're all going to add up to 180. Perfect. So if I'm looking for little alpha, that means I'm going to have 180 minus the 90 we already know with our right angle, minus 61.04. So that means that I've got 61.04. I'm thinking about a million things right now, so I'm going to use my calculator to help me. 28.96 degrees. And again, look back at your triangle to make sense of your answer. We're not asking you to justify anything, but you'll notice little alpha is across from the smallest side, which means that has to be the smallest angle, bringing you back to some geometric theorems. Next biggest one is 8.4, which means that's your next largest angle. And then the largest side should be 9.6, which is across from your 90 degrees. All right, so a couple things to recap. We went through SOHCAHTOA. We also went back through some new reciprocal ratios related to SOHCAHTOA. Then we use these to find missing angles and all things trig in order to solve the triangle. Tonight you have, or today or this morning or whenever it is you're doing this, you've got some bookwork problems. They are going to be also linked on Planbook. Your extension problems for this particular section, lesson 12.1, your extension problems are some story problems related to 12.1 and right triangle trig. So the hardest part of those is just going to be setting up the picture in order to figure out which trig ratio to use. Again, completely optional. If you need some help on this, we will be available during our Zoom sessions tomorrow, Tuesday. Okay, have a great day.